Hello everybody, welcome to another episode of Math with Mr. Emond. Today we're going to be starting our new unit, radical expressions and equations, and we're going to be looking at converting between mixed and entire radicals. And let's get started. So the first thing we're going to kind of look at here is kind of at the parts of a radical. So the first part that you have is the coefficient. And the coefficient is this part here, right in front. So in this case, it's a 5. Let's look at the radical symbol next. Here's our radical symbol in green. The radical symbol, some of you might have previously called it a square root sign, but now what you're going to learn is there's more than just a square root. There's a cubic root, quartic root, pentic root. So a whole bunch of different roots. So this symbol that you see is, we're just going to call it the radical symbol. And you see every radical symbol from now on, unless it's a square root, is going to have a number above it on the leg portion. And this number is going to be called the index. So a cube root has an index of 3. Finally, what's on the inside of your radical symbol, this is called the radicand. And we're going to be starting off just with a brief introduction as to what the similarities between radicals and exponents are, because there's a number of really key things that you should know about radicals. Like, for example, I think most of us at this point in our math, if you're learning about radicals in high school, you should know that the square root of 9 is 3. And we can just test that, just in case you're not too convinced. You know, we can type in our calculator the square root of 9 and see it is in fact 3. And you might have also learned about exponents. If you have a 9 and you put it to the exponent of 1/2, this is also 3. This one you might need some convincing. If I have 9 and I put it to the exponent of 1/2, it is indeed 3. And that is because a square root sign has an index of 2. And this index actually becomes the denominator of your exponent when you're doing a conversion. And let's test this one more time just to make sure that this works. Let's look at the cube root of 27. What is the cube root of 27? It's 3. And again, just in case you don't believe me, let's do it. Let's do the cube root of 27 and see that it is indeed 3. There you go. And if we were going to do a conversion here, we would still need the inside, so the 27. And what would the 27 be to the exponent of? Not 1/2 because it's not a square root, but 1/3 because it's a cube root. So the index becomes the denominator. And this should equal 3 because the cube root of 27 was 3. 27 to the exponent of 1/3 should be 3. Let's see. And it is. So we know that this works. This is a property of math that is going to be very, very useful in this section. Let's talk about simplest form, because this is really what we're going to be focusing on here in this unit, is converting to simplest form and out of simplest form. So what is simplest form? Its simplest form is when the radicand does not contain a fraction. Okay? So that means that we do not want to see anything like this. Square root of 1 over x. This is no good. We don't want to have a fraction inside as our radicand. And we also really don't want to have any factor which can be removed. And so for this one, we're going to take a look at this, the square root of 18. And I'm just going to scroll down here and look at the square root of 18. We're saying here the square root of 18 is not in simplest form because 18 has a square factor. What does that mean? Well, what are my square factors? What's 2 squared? 2 squared is 4. What's 3 squared? 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. And we could keep going, but I'm not going to because we're probably not going to see things where we're using square factors that are that big. Okay, let's look at this then. So if we had the square root of 18, does 18, can we break it down with any of these square factors? We can. You see that 9 there. If we do the square root of 9 times 2, is 9 times 2 not 18? It is. These are the same thing. So we have a square factor there, which means that we can remove it. Now, how do we remove it? This is kind of what the whole unit's on. If 9 is 3 squared, and 3 squared times 2 is 18, well, what happens when we have a square under a square root? Let's split this up. So let's look at 3 squared, and then let's use our law of exponents. What did we say the square root sign looks like when it's an exponent? 1/2. What is 3 squared and the squared's being multiplied by the 1/2? Well, that would be 3, and then we have 2 over 1 being multiplied by 1 over 2, which is 3 to the exponent of 2 over 2, and 2 over 2 is 3 to the exponent of 1, which is just 3. So what you see here, and this is a very key process here, what you see is that when you have a square underneath a square root, what happens? The square and the square root cancel each other. And so what I'm going to do from now on is every time I see a square under a square root sign, I'm going to take whatever number that was and I'm going to remove it to the outside. So I have a 3 and I'm left with root 2 because nothing happened to this 2, right? We didn't remove it because there was no square up here. It was a 1. So we simplified it down to 3 root 2. And let's just check in our calculator. If I type in the square root of 18, what does my calculator tell me? 3 root 2. So that is simplest form. I've removed the square factor using my law of exponents. Now the next thing we're going to kind of look at here is, in order to be in simplest form, the denominator cannot contain a radical. What does this mean? This means, I'm just going to erase this real quick. This means that if I have something like this, x over the square root of y, this cannot be. I cannot have a radical in my denominator. That is not simplest form. So I would have to do something to that, and that we are not going to do in this lesson. That's going to be a further lesson where we're going to deal with that. So here we go. Let's start with some examples. Convert each entire radical to a mixed radical in simplest form. Now the thing that I'm going to start off doing, and what I recommend you to do, is to write down my squares. So 2 squared, actually let's just write down what they are. 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, and 100, and we're not going to go further. Now we're going to look at this, 200. Do you see any square factors that factor into 200? Hopefully you can see the 100 there, right? 100 times 2 is 200. And this is what? This is 10 squared, isn't it? So let's just, instead of writing the square root of 200, say 10 squared. And multiply that by 2. And anytime we have a square root sign and a square, what did we say we can do? We can pull that out. So you have 10 root 2. Easy. Let's check our answer. Is the square root of 200 10 root 2? It is. Excellent. Let's do B. So now we have a quartic root. And when we had a square root, we were looking for things that were squared. right? This time we're looking for things that are to the power of 4. Now, one of your laws of exponents, I'm going to work up here in the top right corner. One of your laws of exponents is that x squared times x cubed is x to the power of 5. How does this work? Well, your exponents, when you have two variables that are the same, so we have x and they have different exponents. When you multiply them together, the exponents add together, and 2 plus 3 is 5. So let's use this knowledge here. I'm going to erase this. If I have c to the power of 9, how could I break this down knowing that when I multiply them, they're going to add together? And the way that I'm going to do that is I'm going to have c to the power of 4, and that's because I want my index and this to match, just like I wanted my 2, my squared, and the index to match. C to the power of 4, oops. C to the power of 4 times c to the power of 4 is what? That's c to the power of 8, because you add these together. And what's going to be left? C. 4 plus 4 plus 1 is 9. Now that I have these things matching, I can remove them. Let's remove them to the outside. So I have c and c, and then I have the fourth root of what's left inside, c. C times c is c squared to the fourth root of c. And we're done. Let's look at this. We have 48. How can we break down 48? Good. With a 16. 16 times 3 is 48. And this has an index of 2, so we're looking for 2's. So y squared times y times y. 2 plus 1 is 5. This 16 is 4 squared. I'm just going to write that here. So I might stop doing this on the next slide, but for now I'll continue on with it. Now I have 3 things that are squared, and these things are going to cancel out, right? So I'm going to be able to remove them to the outside. So 4, y, and y. And then in my square root sign, I still have 3y. 4 times y is 4y squared. And inside I still have the 3y. So there we go. Why don't you give it a shot? Pause the video here. Welcome back. Let's take a look at our solutions. Make sure that you're doing it right. Pause the video here. Good. Let's continue on. Example 2. This time we're going to be doing the reverse. We're bringing it back inside the radical. So we're moving in the opposite direction. We're converting mixed radicals to entire radicals. Now what we learned is to remove it out, it needed to be squared on the inside. So if it's not squared on the outside, that means it used to be squared on the inside. So here's our square root sign. We had the 2 in there, and to put the 7 back in, it had to have been squared. That is how we removed it, right? That's how we removed the 7. What is 7 squared? It's 49. So we have 2 times 49. What's 2 times 49? 98. Excellent. Now we need to move a to the power of 4 to the inside. So we have our square root sign. I'm going to start to use parentheses when I do these. So a to the power of 4. And my index is 2, so I'm going to have to square it. Now this is a little different. I'm no longer doing x squared times x cubed and adding them together. There's not two variables here. There's one variable. X squared cubed, what you do is you multiply the 2 and the 3. So this would be x to the power of 6. We're doing 2 times 3 here. So you have to be careful about which law of exponents you're going to be using. In this case, we are multiplying our exponents. And what was still on the inside, we still had this a there. So don't forget that a. What's a to the power of 4 squared? It's a to the power of 8 times a. Now, this is a to the power of 1, right? Now we're using that first property where we have the similar variables with exponents, and what do? We add them together. So this is a to the 9. Yeah, I could probably write that a little better, couldn't I? A to the power of 9. Good. Let's do that again. We have a cube root now. We're going to move the 5b on the inside. And what are we going to do with it? It's a cubic function. We're going to cube it. And on the inside, we have 3b squared still there. What is 5 cubed? 5 cubed is 125. What is b cubed? Oh, it's b cubed. And then we're multiplying that by 3b squared. What's 125 times 3? (125 times 3 is 375. And what's b squared times b cubed? B to the power of 5. Excellent. Why don't you give this a shot? Pause the video here. I'm going to give you a second to pause and do these questions now. Welcome back. Let's check your solutions. So we've got them boxed here. For A, it was root 48. For B, it was the square root of x to the power of 7. And for C, it was the cube root of 32k to the power of 7. If you didn't get these solutions, pause the video here and look at the work and make sure you know how to do it. Let's move on. Example 3. Order the following from least to greatest without changing the radicals to a decimal. So some of you are going to be a little tempted here to use your calculator and go 3 root 3 and see, oh, that didn't help me because of the way I've got my calculator set up. So I'll press menu, number, convert to decimal, and there we go. 3 root 3, this is equal to 5.19615. And this is definitely bigger than 5. You could do this, but without changing the radicals to decimals. This is hinting that what I want you to be able to do is do this without a calculator. And in fact, the test that you get for this likely will not let you use a calculator. So how do you do this? Well, we would probably have to, the best solution would be to convert them all to entire radicals. So let's do that. If I had a square root sign and the 5 was outside of it, how would I get it back in? Well, I would put it inside my square root sign and I would square it. The square root of 5 squared is the square root of 25. Is the square root of 25 5? Yeah, 5 squared is 25. Good. Let's do the same thing here. So we're going to have our square root sign, 3 squared by moving this 3 back in. And we still have the 3 there. 3 squared is 9. 9 times 3 is the square root of 27. Let's move this 2 back in. Square root of 2 squared times 6. 2 squared is 4. 4 times 6 is the square root of 24. And this one's already done. Square root of 23. So now we can order them from least to greatest. We didn't need a calculator after all. This one's the smallest. And we're going to write it in the form that it was in the question. So root 23. What's the next one? this one, and that's 2 root 6. The next one is root 25, and that was 5. And finally, 3 root 3 is the biggest. Here's my boxed final answer. I hope you enjoy this video. Do your questions for homework, and I will see you next class. Have a good day.